So Steve is our next speaker, and I think at this time he was going to speak his second talk, which is Spectra from an Occultation of IO by Europa. Take it away, Steve.
Okay, go on, next slide. Okay, so I purchased a ALPI spectrometer. This is from Sheliak about a year ago now, and looking for things to do with it, you know. So I wanted to see how I could do with a changing event. I had been using it for looking at comets and things of that sort before this. So I wanted to look at it, see what I would have to do to the hardware and the methods I was using in order to get better data quality in the future. It was a rather spur-of-the-moment opportunity to do this observation. You know, I think it was a Sunday night or something like that. I actually wasn't busy, and it was actually clear. And I didn't really pre-plan what I was doing. I just went out to the observatory, set up the spectrometer, and pointed it at the moon's Jupiter. Next slide. So it was Europa occulting IO. It was May 11th. Minimum distance was 0.6 arc seconds. Decrease in flux 1.6 was expected. And I was hampered by high cirrus clouds that came through right at mid-event time, of course. The early part of the observations were cloud-free. Next. So I used my C14 on a CG mount. I was running at about F4, and I had the ALPI with its slit jaw camera in place, using an ATIC 383 for the Spectra, and an ATIC Titan for guiding the slit jaw camera, so to speak. Slit width was about 3 arc seconds and about 0.1 degree long. Next slide. So here's what the ALPI looks like for those who haven't seen these. The telescope would be over here. There's a calibration unit that has a flat field lamp and has a...
There's your pointer.
Thank you.
You can speak into the mics.
Yeah, has a line source lamp, mercury, neon, hydrogen lamp in here. It also has a flat fielding lamp. The grism is in here. There's a reflecting slit that directs the light back up into the Titan, and then the spectrum goes on to the 383. Next slide. So, of course, since we're in the plane with the moons this year, the moons were very well aligned, and I was able to align all the moons along the slit, though I didn't concern myself much with Callisto and Ganymede. But most of the time they were all in the slit at the same time. I was doing manually guiding across the slit only. Drift along the slit was small enough I didn't worry about that. There was a significant issue with the scattered light from Jupiter, both inside and outside the two moons I was looking at. So I did try to attempt to subtract the scattered light in the analysis I did. My integrations were 5 seconds, and I continually collected data for roughly a half hour on either side of the event. Next slide. So the calibration I tried to do, I did bias subtraction, dark subtraction. I didn't end up doing flats. I just ran out of time in doing my analysis. And I did do wavelength calibration, actually 2 different ways. So here's what the raw image looks like. Jupiter's the bright saturated in the middle. Here's zero order. I guess you can't see the labels here. I think that's Ganymede and Callisto's on the bottom. And here is Io and Europa right under Jupiter there. And there's my wavelength cal roughly. Okay, next. So before, while they were well separated, this was about 20 minutes before, and I could definitely see a separation between the two lines from Europa and Io. There's bin numbers here, by the way, and then wavelength cal is down on the bottom down here in nanometers. And if I just looked at Io, this is what I got. Next one. And Europa looks like this. Now, unfortunately, when I started looking at this in detail, Io should be more shifted towards the red. And if you look at it, there's hardly any difference I got between the two of them. Okay, next. And then at the same time, I also combined the both. So I set my window so I got both moons at the same time and added them together, and I got that spectrum. And this is sort of what I was comparing to as I would go through as it became closer to event time. Okay, is this, you already switched to the next one? Okay, so this is 11 minutes roughly beforehand. And just go ahead and go through them, Ted, because it just gets closer to event time. I've got analysis every couple of minutes. So there's 9 minutes. And there really isn't, there just seems to be noise in what's changing. You know, things will pop up and go down. I'll talk about why I think that's going on at the end. So that's 5 minutes beforehand. I think this is almost, they're almost starting the occultation. There it is, right, this one. Okay, and the next one should be the mid one. Yeah, there's mid. And then last contact should be next. You can see there's not much going on. There's no dramatic changes I'm seeing, but there is a lot of noise in there. So if there were minor changes, I wouldn't be able to tell. And there should be when they're overlapping each other, because the two moons do have a somewhat different spectrum. Is that the last of the spectra? Go ahead, go to the last slide then. Okay, so my conclusions that the clouds I know significantly were impacting me. If I looked at the total signal level at mid-occultation from everything, it was way down, probably a factor of 2 or so. The narrow slit combined with the relative poor tracking of my mount, this is a old CGE Celestron mount that is really right up at its limit with my C14 on there and the spectrometer and the cameras and all. So the tracking is pretty poor with that mount. And I think it's really too narrow a slit for me to really know I had the moons in there the entire time. Certainly the spectral resolution I'm getting out of the ALPI, they claim 600. I think it's more like 400 or 500, at least my unit is. Is really overkill for looking for any type of changes like this. So Shellyak is now making a photometric slit for the ALPI, which is a 2/3 of the slit I have now. So it's got a 3 arc-second slit for me over 2/3 of its length. And then it has a much wider slit, about 10 times wider slit for the last millimeter. So with that, you could put the moons in the wider slit, and then you're not going to worry about losing light at all, because the slit's so wide, my mount should be able to easily hold that. And the Jupiter stray light issue, of course, if I go to a wider slit, my stray light issue is just going to get worse. So that'll be a trade-off to see is it helping or not helping to try that. So I think that's my last slide. So I really don't have any conclusion whether anything changed or not. I think there's a lot of things I could do better in the future, but you know, it's a start. It's a first shot.
You're talking about a slit that has approximately 3 arcseconds in width.
Yeah.
And the diameter of Europa and Io are each about 1 arcsecond.
Mm-hmm.
So why don't you just use a slitless spectra?
Yeah, you could. You could just use like the gratings you insert in front of your camera. That would certainly work in course as well. Right. But then you're going to have a real stray light issue, right? Because the slit is excluding a huge amount of stray light for you.
And just so that it's completely unseen, and then just have the slitless
Yeah, that's another way to do it, sure. But this is the tool I have right here. So.
I was just wondering.
Any other questions? Terry? I was trying to find how to spend my Sunday night. So I didn't have any hopes, Terry. I went in and it was like, hey, I wonder if I can do this. And like I said, I was sort of winging it on the fly. When I first started, I was taking like 1 second exposures, and it's like, oh, I'll go to 5 second exposures. There wasn't a plan.
Let me rephrase the question.
Yeah.
You're looking for the spectrum of Jupiter that's compared to the spectrum of a second of a moon, and then a second moon to see what the difference was.
Yeah, when they started to overlap, I would, you know,
Difference in the shape of the.
yeah, and if you look at them,
You're saying that the noise is.
it's just bouncing around, and there was, you know, if it was following a certain pattern continually, then maybe you could say, oh, something's happening here, but it was like, 1 minute it was this way, 1 minute it was that way, and then it was back the other way.
And I'm curious, do you allow that spectrum overflowing?
Oh, sorry.
Like this? Do the clouds affect the spectrum when you work with an instrument like this? In other words, do they function like a filter and change the spectrum?
I think they're more like an ND filter, at least they should be, but, you know, I was just playing around, and this is what I got. So, you know, it's like, here's a potential tool. You know, do we go with the, like Roger's talking about, and just use a grating, slitless spectrometer?
The price is coming down on some of these instruments that are becoming more rich and astronomers. I had an interest in them, but I haven't really known what I might do with one in terms of contributing science.
By the way, the Alpha is kind of nice in the way they do it because it's modular. So you can get the base Alpha module that's just the Grism for like $600 or $700, and then you can add the slit jaw camera to it, which is about another $600 or $700 when you want to. That has a huge advantage of being able to see what you're putting down the slit. Some of the other spectrometers that are available don't have a good way of watching what you have going down the slit. And then you can add the Cal module, which is another $600 or $700. So you can, you know, build up and build your system slowly. Anybody else? Okay, thank you.